In this tutorial, we are going to create Space Invaders in Pygame. And this can be either in a modern style or with a retro overlay. I will cover both. Now, this is a slightly more advanced Pygame tutorial, so I assume that you already know the basics. However, if you don't or you want a refresher, I have made an extensive Pygame tutorial that would prepare you perfectly for this video. So check this one out if you're a bit lost. And this is only going to be the first advanced Pygame tutorial, and there will be quite a few more. The next one is going to be a Mario-style platformer with pirates, so get subscribed if you don't want to miss it. Also, you can check my Twitter for updates on what I work on and let me know in the comments if you would like to see a game in the future. But with all of that covered, let's go into the game and I hope you enjoy. Alrighty, so let's get started with the first part of this game. And for now, we are only going to set up the main window and the class that is going to contain the logic of the entire game. So for now, we're not really going to draw anything, we're just setting up the actual game. So let's jump straight into Pygame and let's have a look at this. And in here, I already have a couple of things open. Most importantly, we have the basic Pygame setup, nothing fancy happens here. Then I set the display width and height and use those to create a display surface. And that one we call later down here to limit the frame rate. And then in the actual game loop, we are checking for the escape button, we are drawing a background color, and then we are drawing anything that was drawn in the game loop. So this entire thing right now is essentially the most basic setup for Pygame that doesn't do much yet. So if you execute all of this, you would get a blank window with a darkish background. So really not much is happening here. And this code isn't going to change all that much because most of our game logic happens inside of a class. And all we do in here is create an instance of the class and run one method of that class in the game loop. However, there is one change I would like to make. And that is, I want to place this entire code inside of an if statement. That if dunder name is equal to the string dunder main. And if I execute this code, we are not going to get any kind of change. And the reason why I am using this if statement is because we are going to work with multiple files. So there's a very small chance that you might execute some code you don't actually intend to run. And this if statement prevents that entirely. So it's essentially a safeguard that we didn't necessarily need, but it is good practice. So now we have our basic setup. Now with that covered, I want to create a class. And this I called game because it contains the game logic. And for now, this class is going to have two methods. One is the init method. That for now doesn't do anything, so I just add pass in here. And then I also want a method called run. And this one also gets a pass, so we don't get an error message. So let's talk about these two methods. Init is the usual initiate method of a class, and we are essentially going to add lots of sprite groups here. For example, the player is a sprite group, the obstacles and aliens are sprite groups each, and stuff like that. And that is essentially going to be the framework of our game. And then in the run method, we are going to update all sprite groups and we are going to draw all sprite groups. So this run method is essentially the main part of our game. So in the if statement, I want to create an instance of this game. And then in the game loop, I want to run game.run. And that way we can add all of our game logic in this game.run and write the actual code inside of this class. And this is a nice setup to keep our actual game loop clean and have all of the logic inside of a class. And that should make running the entire game much simpler. And alrighty, with that, we already have the basic framework for our game. Now, obviously right now, it really doesn't do all that much, but that we can start working on now. And the first thing I want to work on is the player. And the player will have to do a couple of different things. It needs to show an image of the player itself. It needs to be able to move. It needs to be constrained to the screen, so we can't move outside of it. And it has to be able to shoot a laser and to recharge, which basically means there's a timer between shooting a laser, so the player can't shoot continuously. And all of this is going to happen inside of a sprite class. So we keep the entire code organized and have one class for the player. So let's jump straight back into the code and let's have a look at this. So here I am back in my main file and I want to create a new one. So let me create a new one and let me save it. and I'm going to call this one player.py. And in here, first of all, I want to import Pygame. And next up, I want to create a player class. And this one has to inherit from pygame.sprite.sprite. And in here, as always, we need the init method, needs self, and for now, nothing else. And first of all, we need super.init. Very easy to forget, but very important. And now, like any other sprite class, we are going to need self.image, and we are going to need self.rect. And both of those are very easy to get. For the image itself, I just want to import an image. So pygame.image.load, and the file path is going to be this one. So we are going to the parent folder, and there's a folder called graphics, and in there's an image called player.png. And I want to convert alpha this image. And now for the rectangle, I want to grab my self.image and get the rectangle, and I want to place the mid bottom. And where I want to place it is going to be a position that we are going to get when we initiate this class. So effectively, this position here is going to be a tuple that we pass in here. And alrighty, this is going to be the most basic setup for a sprite class. And now you should be able to call this class inside of our main file. And this could actually be a really good exercise that I want you guys to do two things. First of all, add one attribute to our game class that is called player. And this player is going to be a group single that contains the player sprite. And then in our run method, I want you guys to draw this class. And this should be somewhere on the screen. It doesn't really matter where. Ideally, put it somewhere in the bottom. All right, so first of all, I want to create self.player in my game class. And this is going to be pygame.sprite.group single. And in here, we have to add our player. Although in my case, I first want to create a player sprite. And this is going to be player with a certain position. Let's say for now, I want to place it right in the middle of the screen, so 300 and 300. However, if we were to run this player, we would get an error because this doesn't exist in our file yet, because we have to import it. And well, all I have to do is from player, import player. So we want to import this player file here, and from this file, we want to import this player. And once we have that, I want to put this player sprite inside of my group single. And now we have a group single with one sprite inside. So inside of our run method, we can call self.player, and I want to draw this, and I want to draw this on the surface screen, which is going to be our display surface. And now let me run the code to see if this is working. And indeed, there we can see our player. So this is working quite well. But now, obviously, we want this player to be at the bottom of the screen. So instead of placing it in the middle, in the y-axis, this should be 600. Or even better, this should be screen height, and the x-coordinate should be screen width over 2. And now let's run this again. There we go. Now our player is in the bottom middle of the screen, for the simple reason that we have first gotten this screen width and divided it by 2, so it's going to be half of the screen, and the bottom of the player is at this position here, at 600. And since this is going to be the bottom border, this puts our player also at the bottom border. This is already a pretty good start. So with that, we can start working on the player input. And this also happens in the class. And let's call this one get input. It needs self as usual, but nothing else. And in here, we first of all want to get all the keys. And for that, we need pygame.key.get_pressed. And now we can check different keys being pressed. So if keys pygame.kwrite, so we're pressing the right arrow down. And if that is the case, I want to grab self.rect and move it somewhere to the right. And the amount I want to move it, I want to define in self.speed. So when we initiate the class, I want self.speed. And let's say for now, we can put this down to a 5. So whenever we're pressing the right button, our player rectangles move to the right, so the entire thing is being moved to the right. Now, along with that, we also want to do the same thing for pygame.k left. And this time it would be self.rect minus equals self.speed. And with that, we would have, at least for now, all the input we are going to need. And next up, I want to create an update method. And in this update method for now, we just call getInput. And this needs to be self.getInput. So now if I go back to my game class, I can call self.player.update, and this should be working. So let's try. And it is not working. For the simple reason that this should not be the rectangle, it should be rect.x, because we're only moving in one direction. But now let's try this again, and now it is going to work. So with that, we can move our player left and right. However, there's one problem. Our player can move outside of the screen. So that's not great. And this could actually be a really good exercise for you to work on, that I want you guys to figure out how to constrain the player to the actual window. And this should happen inside of the player class. Let's start working on it. And first of all, our player has to know how wide the screen is. So when I'm initiating the class here, I want to add another argument, and that is going to be the screen width. And while we're at it, I think it's also a good idea to determine the speed of the player in here. So I'm going to add another variable for the speed. So this is the maximum constraint of the player, and this is the speed. So with that, let's go back. And here we have to define a constraint and a speed. And the speed is the easier part. We just add speed in here. And now I'm going to add another attribute that is going to be max x constraint. And this one is going to get my constraint. And now this attribute we can use to constrain the player. And this I'm going to do by creating another method. And let's call this one constraint. And in here, we don't really have to do all that much. All we really want to do is to check the left and the right side of the player. So if self.rect.left, for example, is smaller or equal to 0, because that's our left side. And if that is the case, I want to set the self.rect.left exactly to 0. So essentially what is happening here is that whenever our player is further to the left than the screen, we are placing the player right on the left side of the screen. And we can also do the same thing for self.rect.right if this is greater or equal to self.maxxconstraint. And if that is the case, self.rect.right is going to be exactly on that point. And that is literally all we needed to make this work. So let's call self.constraint. Let's save the file. And let's run our main game, and let's try this again. And there you can see this is working quite well, that the player cannot leave the screen, which feels much more realistic. Now, with that part covered, we can add the laser shooting mechanic of the player. And this is going to be another part in our getInput method. And really, all I want to do in here is if keys pygame.k_space, so we're pressing the space button, then I want to run a method. And let's call this self.shootLaser. And obviously now we are going to need that method. So define shootLaser needs self and nothing else. However, right now we can't really create the entire laser yet, for the simple reason that the laser is going to be its own sprite class that we simply spawn in here. And we haven't created the laser yet, so we can't use it. Instead, I'm just going to print shoot laser for now. And we're going to change this in just a bit. And let me save the file. And let's test if this is going to work. So now, if I press space, you can see in the bottom right that we are shooting the laser multiple times. And this is actually one of the problems that we have to address, that this laser needs a timer. Because if there wasn't a timer, the player could simply keep on pressing space and shoot forever, which would make the game very simple, which we want to avoid. So in our player class, we have to add a timer. And that is going to work with a couple of different variables. First of all, I create a variable called ready. And by default, it is going to be true. Then I want a variable called self.laserTime, which is going to tell us when we have shot the laser, and by default this is 0. Then I want self.laserCoolDown, and this is going to be 600. So we will be able to shoot a laser every 600 milliseconds. And we will only be able to shoot a laser if we are pressing space and if self.ready. And every time we have shot a laser, self.ready is going to be false. So if I just have this set up, we should be able to shoot at least once, but not multiple times. And now if I keep on pressing space, we can't see anything, but we have shot our laser once. So this is working, at least for now. But we do want a way to set ready back to true again. And for that, we have to add a little bit more here. First of all, I want self.laserTime is equal to pygame.time.get ticks. So we are measuring the time since our game has started. And now, let me put it right below. We need another method that I have called recharge. It does not need any arguments besides self. And in here, we are first going to check if not self-ready. So if we have to recharge the laser. If that is the case, we want to check our current time. And for that, we need pygame.time.get ticks. The very same line we have used up here. The only difference here is that this get ticks is only used once. So we're getting 1 point in time. Whereas this get ticks here is being run continuously. So we get multiple times. And that difference is very important because we can use that very well. And what we want to do is to check if our current time minus self.laserTime is greater or equal than our self.laserCoolDown. And let me visualize this on a timeline. So here we have the entire time of our game. And let me use a different color for this. That, let's say, on this point here, we have our laser being shot. And let's say hypothetically, this is at 1000. So this is our current time. Let's say at this point here, we are going to be at 1100. At this point here, we are at 1400. And then at some point here, we are going to be at 1600. And really, all we are going to do is we are checking this time and subtracting our starting time from that. And in this case, this would be 100. If we use this case here, this would be 400. However, if we get to this case here, this would be 600. And as a consequence, this if statement down here would trigger. And that way we have a timer. So if this timer triggers, we want to set self.ready back to true. And now obviously what we have to do, we have to call self.recharge. And that should be all we need for the timer. So now let me keep on pressing space. And you can see that we only get the laser ever so often. So this is working really well. And with that, we pretty much have most of the player class ready. There is very little we actually have to add to this. The most important thing, and let me minimize everything else, is that we have to be able to create a laser. And right now, that doesn't exist. So let's start working on the laser. And the laser is going to be incredibly simple, because at the end of the day, it is literally just a sprite class with a position and a speed. And really, what we are going to do, whenever the player presses space, we are going to spawn a laser sprite in the position of the player and move it upwards. And then later on, we're going to use the same laser class to spawn it in the position of an alien whenever they shoot and then move it downwards. But that's really all it does. It's essentially a sprite class with a position and a speed. And well, that's it. So let's jump back into our code and let's create it. here I'm back in my code. I have main and player. And I want to create a new class that I'm going to save as laser.py. And here again, we have to import Pygame. And again, I want to create a class that I call laser. And this one again has to inherit from pygame.sprite.sprite. And here, as always, we need our init method, needs self for now, and we need super, and then dunder init again. And now, first of all, we are going to need self.image and self.rect as always. And here we don't even have a graphics. Instead, I just create pygame.surface, so an empty surface. And this I have set to a width of 4 and a height of 20. And then for pygame.rect, we get our self.image.getRect. And in here, I set the center to a specific position. And this position, again, I am going to get when we initiate the class. And there's one more thing I would like to add, and that is the image needs to be filled, because right now it's black, which wouldn't look particularly good. And I just want to fill it with white. And that, again, is a very simple setup for our laser. So now I can save this file and go back to my player. And now I want to import from laser, import laser. And now every time this laser shoot is being run, I want to create one instance of this laser class. And for that, first of all, I am going to need a sprite class. So in the init method, self.lasers, and this is going to be pygame.sprite.group. And now every time we are running shoot laser, I want to get my self.lasers and add laser. And now this is going to need a position. And this position I can get from self.rect.center. So literally all that's going to happen is every time we are shooting a laser, we are creating a new sprite in the position of our player. So now I can save the code and I can run the entire game. And now if I press space, nothing is going to happen. For the simple reason that we are not drawing any of these lasers. And that I would like to do in this run method, because that gives me the most control over where stuff is being drawn. And well, all I want to do is self.player.sprite.lasers.draw, and this has to be on screen. And let me put it below the update method, so we are separating updating and drawing. And now we should be able to see the lasers. So let me run all of this again. Now I press space, and now we can see a laser being spawned. Now obviously right now they're not moving upwards, so that's what we have to work on next. But we do have a start. And this could actually be a really good exercise for you, that I want you guys to add a little bit of code to move the lasers upwards. So try to figure this out yourself. Alrighty, let's try it together. So back in my laser class, I want to set a speed. And then this is going to be self.speed is equal to speed. And now this laser is going to get an update method that we are going to get self.rect.y minus equal self.speed. And really all we're doing here, we are moving the rectangle upwards by a certain speed. And since most of our lasers are going to move upwards, we can add a default argument in here. Let's put it to -8. That I think looked good. And now in our player class, what we have to do is to update this laser. So self.lasers.update. And now when we create our laser here, we could add another argument. But since we have a default argument, we don't necessarily have to. But by itself, this should already work. So let's try. Now, if I press space, nothing is working. And that is because this has to be plus equals self.speed. Because right now we are at -8 and we subtracted -8, so it became positive. So our laser moved downwards. But now if we have this for positive, let's try this again. Now we have a laser that is already working really well. So this is going quite well. Nice. But there's one more thing that I do have to add here. That right now, these lasers never disappear. So we have to destroy them once they leave the screen. And let's call it destroy. And all we want to check is if self.rect.y is either smaller or equal to -50, let's say, or if self.rect.y is greater or equal to the height of the window. So this would be 650. However, I want the game to be flexible so we can make it larger. So we need to get this number. And this has to be another argument. So screen height. So let's call it height y constraint. And this is going to be screen height. And then in here, self.height y constraint, and let's add 50 just to have a little bit of wiggle room. And if that is the case, we have to run self.kill to destroy the sprite entirely. And don't forget to actually call the function. So self.destroy in our update method. And now when we create the laser, we have to add this argument as well. So in here, when we create our laser, let's say now I want to go with -8 for the speed. And in here, we do have a minor problem now for the y constraint, because we didn't actually pass that in, we only have the x position. However, what we do have is the bottom of the player. So this self.rectangle, we just want to get the bottom. So self.rect.bottom. And this is actually a fairly realistic way that whenever the laser is below our player, we want to destroy it, which I think does start to make sense. And well, that should be it. Let's try to run the game now. And oh, well, we have a non-default argument follows a default argument. So let's get rid of this -8. And now it works. Our laser still works. You can't really see the laser disappearing, but now our game should not spawn infinite lasers. So this is going to help our game be slightly more efficient. And with that, we have both our player and our laser. And that's literally all we have to do for both of these. Later on, we are going to do a bit with collision, but that happens inside of our main class, not inside the player or the laser. And that means we already finished a major part of this game. Now, with that covered, we have two topics to address. One is the placement of the aliens, and number two is the placement of the obstacles. And they are independent of each other, so it really doesn't matter which one we are going to start with. And both of these are done in very similar ways. So if you understand one, you probably are going to understand the other fairly easily. And let's start with the obstacle. I think that is going to be the easier one. And let me first explain how the obstacle is going to work. And here you can see one of the obstacles on the screen. And it looks like this is one solid figure, but that actually isn't the case. Instead, this obstacle consists of individual blocks, and each of these blocks is a sprite. And really all I have done is I have arranged all of the sprites in such a way that they look like the obstacle. But that is literally it. All that you are looking at is a couple of square-shaped sprites in a certain shape. So we have to figure out how to create this kind of shape. And for that, we are going to need a nested for loop with the enumerate method. So let me explain how this is going to work. And here is how this would look like in code, at least in a more generalized way. Essentially, what we are going to have is a list with strings inside. And each string is going to be one row of our obstacle. And this would be our first for loop. And here we use the enumerate method to figure out on which row we are on. And then a nested for loop is going to look at each individual column inside of this row. And again, we are going to use the enumerate method to figure out on what column we are on. And if you combine these two enumerate methods, you get a grid with specific positions. So for example, the top left would be 0 and 0, and to the right of that, we would have 1 and 0, and to the bottom of that, we would have 0 and 1. And this we can then use to place elements on the screen. And we can even make this more flexible by adding offsets, for example, to move all of the shapes in a certain direction. But that's literally it. It really isn't all that hard when it comes down to it. But alright, that again was a lot of talk. So let me actually implement and let's create one obstacle. And once we have that, we can create multiple. And here we are back in the code. And the first thing I want to do is to create a new file. And I want to save this one as obstacle.py. And here again, we need to import Pygame. And in here, I want to create a class that I call block. And this one again is going to be a sprite. So we need pygame.sprite.sprite. Now we need the usual init method with self and nothing else. And then we need super down there init for this one as well. So everything works well. And now we have to create self.image and self.rect. And for the image, literally all I want to get is a surface. And now we have to figure out the size of the surface. And I want to set this from our main class. So what I'm going to do is when I am creating this class, I'm going to set a size. And since we want squares, the size for x and y is going to be the same. So we put size in both of those. So with that, we have our surface. Now, next up, before we get to the rectangle, I want to fill the rectangle with a color. And this color, I also want to set from the main class. So I'm going to place this also as an argument or parameter. And then finally, the rect is self.image.getRect. And here I want to place the top left. And the position I do not know yet. So this is just going to be x and y. And usually for this position here, I use a tuple. So for most other classes, I just write pos. But in this case, I want to have specific control of x and y, which is why I'm going to separate them by each variable. You're going to see in a second why that is helpful. But, well, that's just going to be another parameter for x and y. And that is literally all that we needed. So this is going to be one part of our obstacle. Now, there's one more thing we need outside of the class, and that is the actual shape. And this is going to be a list with strings. And in my case, let me just paste it in. It looks something like this. So let me explain how this shape is going to work. In here, we have lots of strings, and there's two options. We either have an X, so for example this one, or we have a space. So let me use a different color, that here you can see a space. All we are going to do at the end of the day is wherever we have an X, we're going to create a block. So for example, this X here is going to be a block. This X here is going to be a block. All of these X's are going to be a block. And if there's a space, so like this area here, there's not going to be a block. And that way, we are going to recreate this shape as sprites. And for that, we are going to use the function I explained earlier. But this is literally all we needed from our class. So now I can save it and go back to my main file. And first of all, I have to import my obstacle file. And now, before we get into an actual method to create all of this, we have to create a couple of basic variables. And let me actually add a couple more comments to be a bit more specific. So let's call this one player setup. And below that, we have the obstacle setup. I should really use comments more regularly. But all right, the first thing I want to do is to capture the shape of our obstacle. So self.shape. And this is going to be obstacle.shape. So literally this thing here. And that is just to make it a bit easier to work with inside of the game class. Now, next up, I want to set myself.block size. And I set this to a 6. So this is the number we are going to pass in here later on. And finally, we want to have a group that collects all of these sprites we are going to create in just a bit. And I've called this one blocks. And for now, this is just going to be pygame.sprite.group with nothing inside. And that is all we need for basic variables. Now we have to create a function that creates one obstacle. And well, let's call it create obstacle. And for now, we are not going to pass any arguments inside of this, but we are going to pass some in just a bit. And now we have to use the function I talked about earlier. So what we want to do is we want to loop over this shape here. So let's start with for row in self.shape. And each row in here would be one of these rows. Now, the problem with just using self.shape is we wouldn't know on what row we are on. And to get that information, I want to get the enumerate method. And what this one does is it returns an integer on what index we are on. So for example, this would be the index 0, this would be the index 1, the index 2, the index 3, and so on. And this is the information we are going to use to set a certain information for our height, or well, for our row. So once we have that, we know on what row we are on. Now, next up, we have to figure out on what column we are on. And well, for that, I'm going to approach this in a very similar way. So we have call index and call in enumerate, and this is just going to be row. So let me explain again what we are going to do. So let's say we are currently on the first row. So we are in here. Now, each of those items is going to get one index. So this would be 0, this would be 1, then this one here would be 2, and then this one here would be 3. And by using these enumerate methods, we get the specific positions of each of these x's. For example, this x here would have the index 0 and 0, whereas this index here would have the index of 0 and 2, I think. And this is the information we need to place something on the screen. And all right, this is all we needed to find the position. Now, obviously what we want to do is an if statement. So if the column is equal to the letter x, because we want to ignore all the empty spaces. And well, now we have to figure out the x and the y position. And once we have that, we can create one block that is going to be obstacle.block. And now in here, we have to add a couple of arguments. So let me copy them really quick so we can work through them one by one. And the size we already have, it's literally just this one up here. So this one is the easiest one to get. We just want to get self.block size. Next up, the color is also very easy because I have a tuple that I want to use here. And the tuple I want to use is this one. So this one is predefined. And this is a reddish color that I think looks quite good. Now, finally, we need our x and y coordinates. And those we are going to create now. And this could actually be a really good exercise for you. Try to figure out what we have to do for x and y to place each block in the right position. So for x, we obviously have to look at our columns. So this part here. And the first we need is to get our call index. So this would give us a number from 0, 1, 2, 3, 4, and I think the maximum column we have is 11. So the highest number here would be a 10, and the lowest is 0. And this would then be a start. However, we don't just want to move the x by 1 pixel, we want to move it by the size of each block. So each block starts after the previous block has ended. And well, for that, all we need is to multiply the index by self.block size. And well, that's literally all we need to get this thing started. Now for y, we are going to do basically the same, except now we use the row index, but we're still going to multiply it by self.block size. And well, with that, we have our basic block. Now the final thing we have to do in here is to get our self.blocks and add the block we have made to it. And that is already going to be a really good start. Now, what I want to do is when we initiate the class, I just want to run self.createObstacle. And then in our game method, I want to get my self.blocks and draw all of them on the screen. And let's just see what happens. And there you can see in the top left, we have our first obstacle. So this is actually already working. Now, obviously, the obstacle isn't supposed to be in the top left. So that's something we do have to work on. But, well, it's a good start. So what we have to work on now is to offset all of this to place all of them a bit further down. And, well, that isn't all that difficult because literally all I want to do is to set an x start variable and a y start variable. And then every time we are placing either the x or the y, we want to add this number towards them. So x start plus all of this, or y start plus all of this. And now when we create our obstacle, we can pass a number in here. Let's say for x, we can start with 40, and for y, I think I went with 480. And now let's try this. and we are getting an error because I made a typo. There we go. This is looking much better. So now we have one obstacle. Doesn't do anything yet, but that we're going to cover later on. But this is going to be our first obstacle. So alrighty, with that, we have our first one. And now what you could be doing is to run this function 4 times and figure out the positions by yourself. And that would be an approach, but not an approach I would like, because that seems like a lot of writing. Instead, what I have done is I created another function. And this I have called create multiple obstacles. And first of all, here we are going to need self. Then besides that, I want to pass in the x start. And this would be the same x start we have used here. I just want to be able to call it from this function. Because literally what we are going to do is I'm going to call this function only inside of this method here. I am not going to call it inside of the init method directly. And I also want to do the same for y start. And next up, I have to get some kind of offset. So I have to know what the distance between each of the obstacles is going to be. And in my case, I don't actually know how many obstacles I am going to have. So I want to use a parameter that I can later use to add as many arguments as I want. And this is going to look like this. I use a star and then offset. And that's called an unpacking operator. And that's going to be super useful. And now what I want to do in this function is for x in offset. So all the arguments we are going to pass in here, we are going to loop over. And then in here, we are going to run self.createObstacle. And now we have to pass in a couple of arguments. The first two are the easy ones because we already have our size and our color. So for now, we have to figure out these two arguments to pass in here. And well, they're not that hard because we already have x start and we have y start. But now there's one more thing we have to do, that we have to get the offset in here as well. So what I want to do is to add my x variable in here as well. So the one we have just looped over. But for that to work, we have to add another argument in here, and that I called offset x. And actually, let me name things properly. So instead of for x, it's offset x, and then we place all of this in here. So this should make this a bit easier to read. And with that, we have the two functions we need to make all of this work. So now inside of my init class, I want to create multiple obstacles. And again, let me copy the parameters we need to work through this one by one. First of all, we will need the x start. And let me just place a 0 in here, so we start the left side of the screen. For y start, I just want to go with 480, because I think that number worked quite well. And now for the offset, for now, let me just place in a couple of random numbers. So let's start with 0, then 100, and then 200. And there's one thing I did forget, and that is this line here, that I want to add my offset x. And let me quickly go through this line because that is the really important one. So essentially what happens in here is this line is the really important bit, because this is what we are going to use to check what position we are on inside of our shape. And then we are going to offset this position twice. First of all, we are going to get a start position. So this is going to be how far we are from the left. And then plus that, we are going to create another offset. And this ensures that if we have multiple obstacles, they're not all on the same position. Because if we didn't include this line here, they would all be on the same position. But we want to use this information here to offset each obstacle. So the first one is going to start at 0, but then the second one is going to be 100 pixels further to the right. And the next one is going to be 200 pixels further to the right. And that way we can get all of our obstacles. So let's try this. And we are getting an error message because I made a silly mistake that this here should not be in a tuple. It should just be numbers by themselves because this offset already places them in a tuple. So now let's try this again. And now we can see all of our obstacles. Obviously not in the right position and we are missing one, but we can work on that. And I think right now this line here is very difficult to read. So instead I want to use named arguments in here. But we can't use positional arguments after named arguments. So I want to move this x start and y start after the offset. So I also want to move those two to the end. And now I can call them X start, and I can call them Y start. And all the stuff we have in the beginning is just going to be the offset. And let's try this again, and it's still working just fine. So now what we do have to figure out is how to space our obstacles in the right amount. And this again, I want to be flexible, so we can make the screen larger or smaller, and it shouldn't really matter. And I also want to have flexibility over how many obstacles I am going to have. So I'm going to add another attribute that I called obstacle amount. And I just went with 4. And now with that information, I'm going to create another attribute that I have called obstacle x positions. And now we have to figure out how to get these positions here that space out the entire screen. And let's start building this thing up step by step. So first of all, I want to get num for num in range, and this is going to be self.obstacle amount. So for now, we would get a list with the numbers 0, 1, 2, and 3, because our highest number is 4, and we're just looping over it. And well, all we have to do now with that is to multiply that number with our screen width divided by self.obstacle amount. And that is a slightly longer line now. But let me go over what's going to happen in here. We're going to start with this number. And this number is either going to be 0, 1, 2, or 3. And for the sake of an example, let's assume that this number here is 2. Then we're going to multiply all of this with screen width divided by obstacle amount. And screen width in our case is going to be 600. And obstacle amount is going to be 4. And if we divide one by the other, we get 150. And if you multiply this by 2, we get a position of 300, which is exactly in the middle of the screen. And then let me use a different color. If we had 3 in there, we would also multiply this by 150, and we would get 450. So a nice offset to the right. And well, with that, we can just pass in self.obstacle x positions in here. However, right now, this would not be working because this is going to be a list, and we just have to pass in individual numbers. So what I have to use again is the unpacking operator. So this star here means that we're going to unpack this list straight away. And well, let's try this. And now we are getting much better. So now we have all of our obstacles nicely spaced out. So now the final problem is that we have no offset on the left. And well, for that, we have our X start. Not this one, we have this X start. Or this one here, that is 0 for now. And for this one, I gotta be honest, I was a little bit lazy because all I did, I went with screen width divided by 15. And if you run this, it kind of looks okay. I'm not sure if the math is entirely correct. You would have to look at it in a bit more detail, but I think this looks good enough. But this probably isn't pixel perfect, but I think this works just fine. So with that, we have our obstacles. And now we can use that knowledge to place all of our aliens. And this is also going to happen with a nested for loop that uses the enumerate method, albeit in a slightly different way. But the broad strokes are essentially the same. And well, there's not much point explaining all of this in too much detail. Let's implement it straight away. So here I am back in the code. And the first thing I want to do is to create a new file that I'm going to save as alien.py. And in here, again, I want to import Pygame and create a new class that I have called alien. This one, again, is going to be a sprite. So we have to do the inheritance thing. We need init with a space in between. It needs self for now. And then we need super and dunder init. All right. And again, we need an image and we need a rectangle. And in here, each image is going to be a graphic we are going to import. So what we first have to figure out is a file path. So let's just call it file path. And here is what I did. Whenever we create an alien, we have to specify a color. So this could be red, yellow, or green. And then in the folder, I have named each file either red, green, or yellow. And what that allows us to do, so I go up a folder, and then I go to graphics, and then I am going to add my color to it. And then I'm going to add the file ending with .png. So if I were to write the string red in here, we would get graphics/red.png, which is exactly what we need for our file path. And that's why I don't have to work with different if statements and our code stays nice and clean. And now I can use that file path to use pygame.image.load, add in my file path, and then convert alpha. The same thing we have seen so many times by now. And then for the rectangle, I want to get myself.image.get rect. And here again, I want to place the top left. And this again is going to be X and Y. So we have to add X and Y in here as well. And that is going to be our basic alien. So this is a pretty good start. And all right, so with that, we can return to our main file and start working with the alien. And first of all, for that, we have to import it. So from alien, import alien. And now in the init method, I want to create a couple of basic setup points. So let's add a comment with alien setup. And in here, for now, I am only going to need a single thing, and that is self.aliens, and that is a pygame.sprite.group. So all the aliens are going to be in this group. And now with that, I want to create a function that is going to create all of these aliens in a specific position. And I call this alien setup. And now let's create this function. So def alien set up. And for now, we are only going to use self. And now let me actually open the create obstacle function as well, because we are effectively going to do the same thing we have done here. So again, I want for row, index, and row in enumerate. And now I want some kind of row, or let's call it rows for now. And in there, for call index and call in enumerate. And for this one, we want to figure out how many columns we have, or calls. And now we have to figure out how many rows and how many columns we want to have for our aliens. And well, that's going to be parameters. So let's start with rows and with columns. So whenever we call the function, we have to specify that information. And once we have that, we have to again create an X and a Y variable. And once we have that, I want to create an alien sprite that is going to be alien. And let me copy the parameters we need. So we need color, X, and Y. And the color is the easiest part because I have a couple of predefined ones. So let's start with red. And then we need X and Y. And once we have that, I want to get myself.aliens and add the alien sprite. So now we have most of the stuff we need. We just need X and Y. And this could actually be a really good exercise for you. Try to work through the logic here and see how you can use this to place the aliens on the screen. And most importantly, try to think about what bits of information you are going to need to enable all of this. Let's start with X. And in here, as always, we are going to need our call index. And the same for Y, we need our row index. So this will give us numbers in the single digits, which is, well, not great yet. Actually, let me pass in specific numbers. And for the rows, I went with 6. And for the calls, I went with 8. So this means this call index is going to be from 0 to 7. And then the row index is going to go from 0 to 5. So let's just see how this would look like right now. And all we need to do for that is in our self.run function, I also want to get my self.aliens.draw and do this on the screen. And now let's run this code. And we get an error message because this rows and this column has to be in a range function. So let's put this inside of range. And now let's try this again. So now in the top left, you can see a reddish blob. And this is not an obstacle, this is an alien. The reason why it is looking so weird is because we have a couple of aliens on top of each other with an offset. So this is what we have to start working on. And here it really helps to look at our earlier create obstacle function. Because for this one, we had essentially 4 bits of information. We had the column index, then we had the size of each block, we had the starting position, and we had the offset. So 4 pieces. And right now, we only have 1. We have the column index. So we have to add a couple of bits of information here. And there are 2 major things we need. The first one is the size. And the other part is the offset. And we don't really need a start variable because our aliens are going to move on the screen anyway. So it doesn't really matter where they are going to start. But we definitely need a size and an offset, both for X and Y. So this is what we have to create. And essentially what that means is we have to create a few more parameters. And the first 2 we need is X distance and Y distance. And literally all I want to do is to multiply each side with the distance we need. So X distance and Y distance. And I think it's a good idea to add some default parameters in here. So let's say for the X distance, by default, this should be 60. And for the Y distance, this should be 48. And now let's try this again. And now this is looking so much better. So now we have an actual proper grid. And if you had more columns or more rows, you could make this more dense or more widespread. It's up to you. But now the obvious problem is that all of our aliens are starting in the top left. So that means we have to give all of this an offset. So we are going to need an X offset and we are going to need a Y offset. And then literally all that we are going to do is to add plus X offset and plus Y offset. And here again, I'm just going to give it some default parameters. Let's say for X offset, we're going to go with 70. And for Y offset, I put in 100. And now let's try this again. And there we go. Now we have our aliens nicely set up on the screen. Still don't do anything, but that's going to come in a second. And with all of the default arguments, we can have our alien setup function nice with a couple of rows and columns. And we don't end up with a ton of arguments in here. So this is working quite well. But now we have another problem. That right now, all of our aliens have the same color. So that's not exactly what I want. And instead, for different rows, I want to have different colors for each alien. And for that, we are going to need a couple of if statements. And here, again, the enumerate method is going to help us enormously, because this is going to tell us what row we are on. For example, if we are on row 0, this one is going to tell us we're on row 0. So this is super helpful. And this is what I need in my if statement. So if row index is equal to 0, so we're on the top row, and if that is the case, I want my alien sprite to be yellow. Now, if that is not the case, and my row index is between 1 and 2, then I want to create an alien sprite that is an alien with the color green. And we again are going to need X and Y. Those stay the same. And now for all the other rows, so else, I want to create an alien sprite that is going to be alien with the color red, and again with X and Y. And now let's try this. And there we go. Now we have nice colors. And let's go through what actually happens here. And the really important line is this one here, because this one is telling what row we are on. So this row here would have the index 0, this row would have the index 1, then 2, and 3, 4, and 5. And this is the information we are using down here, that if we are on row 0, so this one here, then we want to create a yellow alien. However, if we are between 1 and 2, we are on those 2, so we want a green alien. And then for any other case, so 3, 4, and 5, we have the else statement, so we create a red alien. And well, with that logic, we have all of our aliens. So this is working really nicely. And with that, we have our basic alien setup. So now we can close this method and not worry about it ever again. But now the problem is that our aliens are static, so that's not particularly helpful. And to move them, we have to go back to our alien file. And in here, I want to specify an update method. And this one needs self, and it will also need a direction. And really what I want to do in here is self.rect.x plus equal direction. And now we can use this function to update all of the aliens. So if I go back to my main function, let's add all of the update methods right at the beginning. So self.aliens.update. And now here we have to specify how fast our aliens are going to go. And this, I think, should be an attribute of the game class. So let's call it self.alienDirection. And this we are going to create in our init method. Let's place it here. Self.alienDirection. And by default, it's going to be 1. And now let's run this. And now we have all of our aliens moving to the right. Obviously, they don't stop, but that's fine. So now what we have to figure out is if any of the aliens is on the right of the screen, we want to change this number to -1. So all the aliens are moving to the left instead of the right. And this is going to be another function, or well, method. And this I called alien position checker. And here's the logic that's going to make all of this work. Essentially, we are going to cycle through every single alien. And if any of the aliens is too far to the right, we are going to change the direction of all of the aliens. And then the same if any of the aliens is too far to the left or smaller than 0, then we are also going to change the direction again. So first of all, we have to get all aliens. And this is going to be self.aliens.sprites. And don't forget the brackets here, they are really important. We are calling a method. And now we can look for alien in all aliens. So this way we can look at all the sprites individually. And this could be a really good exercise for you, that inside of this for loop, you can access the rect of each alien. So use that in an if statement to change the direction if any of the aliens goes outside of the screen, either left or right. Let's start with the right side. So if any of the alien.rect.right, so the right side of all the aliens, if any of those is greater than the screen width, and now inside of this function, all I want to do is to get my self.alienDirection and set this to -1. And well, this should now be working. So in our run function, we can call self.alienPositionChecker. And don't forget to call it. And now let's run this. And there we go, this is working. Obviously, we don't have a left side, so there they keep on going forever. But this we can work on now, because all we need is an elif statement that checks if alien.rect.left is smaller or equal to 0. And if that is the case, my self.alien.direction is going to be 1. And now the aliens go left, they go right, and all of this is working super well. Cool. So with that, we have our left and right movement. But this is only part of the movement, because what I also want to achieve is anytime our aliens hit either the left or the right side, I want to move them downwards by a couple of pixels. And that is going to be another method. And I have called this one alien move down. And in here, I want to move for alien in self.aliens.sprites. So kind of like what I've done up here, I just check all of the sprites. And literally all I want to do is to get my alien and get the rect and y, so the y position, and just that plus equal a certain distance. And this distance I'm going to specify every time I run this method. And there's one thing I would like to add in here. And that is I want to add all of this inside of an if statement. And the if statement is going to be if self.aliens. So this is only going to be run if they are aliens inside of the alien class. And the reason for that is if the player shot down all of the aliens, so they all disappeared, we don't really want to run this anymore because it would cause an error. So this is a nice way to make our code a bit less buggy. But all right, so with that, we have a distance, and now we have to call this method every time our aliens hit either the left or the right side of the screen. So in here, self.alien move down, and the distance I moved them down was 2. And this function you have to call for both if statements. And well, let's try this. And this is working quite well. So now the aliens are moving down. So with that, we have covered all of the movement of the aliens. Now, the last part we need for them is to give them the ability to shoot lasers. And well, that's going to be just another method that we are going to call once in a while. And let's call it alien_shoot, and it only needs self as always. And let me minimize all the other functions because they start to get a bit annoying. And that feels much better. And in here, I first want to start with the same if statement we used for alien move down. That we only want to run this if they are aliens inside of our aliens group. And if that is the case, I want to select a random alien first. So I want to get a random alien. And for that, I need the random module. So all the way at the top, I want to import from random import choice. And this choice we can then use down here to pick one alien. And this happens with self.aliens.sprites. So this line here literally just selects a single alien out of all of our aliens. And this we are going to use for the X and Y position of the laser. And we still have our laser from earlier. So we can use the position, the speed, and the screen height. So let me copy all of the parameters and let's create a laser sprite. This is going to be laser, and let me pass in all of the arguments we are going to need. And since we're using laser, we also have to import it. So from laser, import laser. And in here, we have to figure out the different arguments. Although screen height is literally just the screen height we are specified down here. So this one is already covered. Next up for the position, all we need is random alien.rect.center. And then we are going to need a speed. And for the alien lasers, I went with 6. But this number is basically random. So now we have a laser. And in here, we have to figure out on what sprite group to add it. And there's going to be a minor problem because we already have one group for lasers, and that is this one here. And this lasers is inside of the player. And we couldn't just add these lasers to this group here for 2 reasons mostly. First of all, it wouldn't really make sense that a sprite class inside of our player shouldn't be used for the alien lasers. Although that is more for the logic of the code itself. It would technically work. However, the second reason would be more important for the game itself. That this laser has to be in a different group than these lasers. Because later on, we are going to check collisions. That if any of these lasers is colliding with the player. And if we were to put all the lasers in one group, we would cause the player to be hit every time the player spawns a laser. Because the laser is drawn right behind the player. So this laser sprite has to be in a separate group. And well, what that means is that we have to create another group. So self.alien lasers and pygame.sprite.group. And let me put it right below the other group. And this is what we're going to add the laser to. So self.alien lasers.add laser sprite. And I hope the logic here makes sense. That the lasers from the player and the lasers from the alien have to be separated, for the simple reason that we are always spawning the laser right behind the relevant sprite. So if we were to spawn a sprite right behind the player and then check for collision between all lasers and the player, we would always hit the player, so this would make the game unplayable. And that's why we need 2 different groups for our lasers. However, now we don't really want to call this function all the time. Or actually, let me call this function all the time and let me demonstrate what's going to happen. So self.alien shoot. Then we have to self.alien lasers.update. And then we have to draw all of the lasers. So self.alien lasers.draw and on the screen. And now if I run this, you can, I think, see why this wouldn't be particularly fair. Or, well, it would be a little bit of a difficult game. So we don't want to run the alien shoot all the time. We want to have a timer in between. And that is going to happen down here. That we want to create a timer. And this happens with, let's call it alien laser. And here we have to create Pygame a user event +1. And then pygame.time.set timer. And now we want to get the alien laser. And now I want to set the time how often this is going to run. I went with 800 milliseconds. So we have one laser shot about once a second. But again, you can make the game more difficult if you reduce this number. And now if event.type is equal to the alien laser, only if that is the case, I want to get my game and run alien shoot. So we don't run this method inside of our run function. Instead, we only run it inside of this timer. And that we can now run. And now we only have a laser that looks much more reasonable. We still don't have any collisions, but that we can start working on. But before we are going to start working on that, I want to add an extra alien. Because a key part of Space Invader is to get a high score, and in the original game there's this top alien coming once in a while at the top of the screen that you can try to hit for extra points. And this alien I also want to include. And for that, we have to create another kind of class in our alien file. And this I called class extra. This also has to be a pygame.sprite.sprite, and as always, it needs a init method, then we need a super init method, and then we're going to need a self.image and a self.rect. And to get the image, we can just use the usual pygame.image.load, and the file path is this one. And then convert alpha as always. So we are just going to import a graphic for the image. But now the rectangle is going to be a little bit more difficult because this extra alien is supposed to either come in from the left and go to the right, or come in from the right and go to the left. So what I want to specify is the side this thing is supposed to start on. And now we have to add an if statement in here. That if side is equal to right, then I want to create an X that is the screen width. And right now we can't access the screen width. So this is going to be another parameter. So screen width. And this is going to be screen width. And let's say +50, just for some bit of wiggle room. And if we are going to write anything other than right, we assume that the extra alien is supposed to start from the left. So the X can just be -50. And now we have all we need for the rectangle. So self.rect is going to be self.image.getRect as always. And in here, I want my top left to be X. And then for Y, I just went with 80. And this code would either spawn the extra on the left or the right side of the screen, depending on what we specify in here. But if we were to add this extra to our aliens, we wouldn't see it because it's outside of the screen. So instead, I want to add a speed to it. So let's give it an update function that is going to get self.rect.x plus equals self.speed. So this speed is either going to be positive or negative depending on what side we are spawning the extra alien. So we have to specify it. So this would be self.speed is equal to, let's say, -3. And then if we are moving to the right, self.speed should just be 3. And that way, if our extra alien is on the right side of the screen, so this one here, we are moving it to the left. And if it is on the left side of the screen, we are moving it to the right. And that way, you should be able to see it once we spawn it in the game. So with that, I can return to my main file. And now you might be tempted, let me go up. You might be tempted to add the extra alien to this aliens.group. but that would not be working. Actually, let me go back and tell you why. Because this alien sprite has a specific update method, because here we are changing the direction of all of the sprites. And also in the alien move down function, we are moving down all of the aliens inside of this group. And this is not something we want to do with our extra alien. It's just supposed to stay on the top. So we couldn't really add the extra alien to the self.aliens group. It just wouldn't work. So instead, we have to create another group. And I just called this one self.extra. And since we only ever want to have a single one of those on the screen, this could be a group single. And I guess we can move this to its own group that is a bit easier to read. Let's call this extra setup. And now this extra alien, I only want to spawn ever so often. And I want to keep this one inside of the function itself. Although you could also add another timer to it, that would also work. But in my case, let's do a couple of different approaches. So what I want to create is self.extra spawn time. And for this, I just want to get a random integer, let's say between 400 and 800. And for that, we need the randint method. So at the top, I want to get my from random import choice and randint. So now let's say this number could be 600. And literally all I'm going to do is every time we are running this self.run method, we are subtracting a certain amount from this number. And whenever it hits 0, we're going to spawn an extra alien. So for that, we have to create another method. And let's call this one extra alien timer. Needs self and nothing else. And now I just want to get my self.extra alien spawn time minus equal 1. And then if my self.extra spawn time is smaller or equal to 0, then I want to get my self.extra group. So this group single, and add an instance of the extra to it. So this would be extra. And in here, we need 2 bits of argument. We first need the side, and then we need the screen width. Unfortunately, the screen width we already have. That one's easy. But now we have to get the side. And this one is just going to be choice. And into choice, we have to pass in a list that is either right or left. And then finally, we have to run this function in there again. So we set up a new timer for the extra spawn time. So essentially what happens in here is we start with a number up here and we get an extra spawn time number. And let's say for the sake of the argument for now, this is going to be 600. Then inside of extra alien timer, we're going to reduce this number by 1. So if we run this once, we get to 599, then 588, and so on. And eventually, we are going to hit 0. And if we hit 0, we're going to run this if statement. And what we do in there on the first line is we're going to create an extra alien that will either spawn on the left or the right side. And well, then we give it a screen width to tell when it's supposed to disappear. And well, that's all we really have to worry about in this instance. And then we are going to set a new random integer. So now instead of 600, let's say we could get 520. So now the next extra alien would spawn a little bit faster. So the only thing we have to worry about now is to actually calling this function. And let's also place it right down here. So self.extra alien timer. And now before we are going to call it, I forgot that we have to import it. So we have from alien, import alien, and extra. And just to test this, I am going to set the spawn time for the first spawn between 40 and 80. So we don't have to wait for too long. So now let's try this. And, oh, right. We are not going to see anything because we are not drawing this extra alien. So in here, we have to get self.extra.draw. This has to be on the screen again. And then we have to update it as well. So self.update. And now let's try this. And there we can see it. we have a nice little extra alien on the top. And if I wait a tiny bit longer, this should reappear at some point. There we go. And now at some point, we should also get one that comes from the left. I think we just got not very lucky for now. And yeah, there we go. So this is also working very well. Cool. So with that, I can minimize this function as well. And we are making some really good progress. So now we have all the players, all the obstacles, and all the aliens. Now we have to work on the collisions to actually turn this into a game. And the collision function is going to be the longest part of this game. However, it's not particularly complicated, because all we are really going to do is we check different sprite collisions. So for the laser sprites, we check with the obstacles and the aliens, and for the alien lasers, we also check with the obstacles, but now with the player. So it should be a fairly straightforward thing to work on. So let's jump into the code and let's have a look at this. And here I am back, and it is getting quite extensive. But right at the bottom, I want to add one more method. And this one I just called collision checks. It needs self and nothing else. And now in here, we have to check a couple of things. And let me start with the player lasers. That is probably going to be the most interesting one. And first of all, I want to check if there are any lasers from the player. So if self.player.sprite.lasers. And if that is the case, I want to look for laser in self.player.sprite.lasers. Bit of an extensive thing, but well. And let me spell this properly as well. That tends to help. And now I want to check for two different things. If either of these lasers connects with the obstacle or with the aliens. And let's start with the obstacle collisions. And really all we need in here is if pygame.sprite.sprite collide. And in here we want one sprite, that's the laser. Then I want to have my self.blocks. So each block of the obstacle. And then I need a third argument, and that's the do kill. And this one should be true, because we want to destroy this block as soon as it collides with the laser. And for now, inside of this if statement, let's just call laser for now. And don't forget to run this function so we can test it properly. So self.collision checks. And now let's try this. And now you can see that this is indeed working and we can destroy the obstacles. Now, obviously, this isn't working as intended because our laser doesn't disappear and keeps on going and destroys all of the obstacles. But this we can change very easily, because all we have to do is we have to get our laser sprite and run kill on it. So essentially what's going to happen in here is when this if statement runs, it destroys the block it's colliding with. And then if that is the case, we are also going to destroy the laser right inside of the if statement. And if we do that, now we have a pretty well working laser with the obstacles. And you can keep on destroying individual parts and then use this in the normal way. So this is literally all we needed to make the basic laser work for the player and the obstacles. Now, next up, we need the alien collisions. And well, for now, we can just copy this entire line and change self.block to self.aliens. And well, that's all we have to make for a change. So now let's try this. And we can also destroy the aliens. So this is also working quite well. Although later on, we are going to make some changes to this line when we add the score, but that comes later. And then we need the final one, and that's the extra collision. And here again, I can just copy this if statement and change this to self.extra. And now, okay, this is going to be very difficult to hit. But I am quite confident that it is going to work. But well, in an actual game, do test this a bit more. But right, so with that, we have our basic collisions for the player. Now, next up, we have to do the exact same thing for the alien lasers. And this could be a really good exercise for you, that I want you guys to create the collision logic for the alien laser colliding with the obstacles and with the player. I first want to check if there are any alien lasers. So if self.alien lasers is the case, and if that is the case, I want to loop over all of the lasers. So for laser again in self.alien lasers. And now for the obstacle collision, I can literally just copy this line here. And well, that's all we had to do. And let's try this. And let's hope an alien hits an obstacle. And yeah, there we go. This is working indeed. Cool. Now we can copy this if statement again. And now we want to check the laser against self.player. And this one has to be false because we don't want to destroy the player. And then here you could close the game, but for now I'm just going to print dead. So let's try this and let's hope I can get hit. There we go. This is working quite well and we can be hit by aliens. So with that, we have the collisions for all of the lasers. And this actually wasn't all that bad. Although, well, we are going to make some additions to this. But there's one more collision that we are going to need. And that is between the aliens themselves and the obstacle blocks. And then I guess with the player as well. Although if an alien collides with the player, we are going to game over immediately anyway. But we do have to work with that. So let's call this one aliens. And in here, I just want to check if let me scroll down, if self.aliens, so if there are any aliens on the screen, I want to check for alien in self.aliens. And now again, I can again check this same line, except now this doesn't have to be an if statement because we don't want to destroy the alien, we just want to destroy the block. And this shouldn't be laser, this should be alien. But we also want to check if an alien collides with the player. So let me copy this line here. So if pygame.sprite.sprite collide, and we want to check between the alien and the player. And if that is the case, I guess then we can close the game. So pygame.quit and sys.exit. And this is going to be kind of annoying to test because we would have to wait quite a while. So just for now, for our alien position checker, I want to set the speed to -10 and +10. So now they should speed up quite a bit. Now our obstacles disappear and we go to game over once the aliens collide with the player. So this is working, cool. So this is actually all we needed for the collisions. Wasn't actually that bad. And with that, we essentially have a game, although not a very good game yet, because we want to add a couple more things. And I think the most important one for Space Invaders is to add a score and a life system. So that's going to be what we start working on now. And let's start with the lives, that I guess is the easier one. And I think this is best approached by just going straight into the code and going through this one by one. So let's start with that. So here you can see the main file again, and I want to work on my init method. And in here, I want to add another section, and let's call this one health and score setup. And in here, we have to specify a couple of different things. Since we are starting with the lives, I want self.lives, and I want to have 3 different lives. And since I want to display all of these lives as the player in the top right, I also need a surface. So let's call this live surface. And for this, we need pygame.image.load. And this is going to be the same file we have for the player. This one here. And then we have to again convert alpha all of this. And there's one more thing that we need. And that is going to be self.liveXStart position. So effectively, we want to place all of these lives in the top right of the screen. But for that, we have to know how far of an offset we need from the right side of the screen. And this is what this is going to be for. And in here, I want to first get my screen width. And from that, I want to subtract a couple of things. And basically what I want to get, first of all, is self.liveSurface.getSize. And this should be 0. So effectively, what we're doing here, we are first getting our live surface, so the thing we have literally just imported. Then I want to get size, and this is going to give me an x and a y parameter. And from that, I only care about the x part, so I'm going to get 0. So this will ultimately get me the width of my life surface. That's literally all this does. So this would give me the width of one player life. But I don't just want to show one, I want to show two. And then along with that, I also want to have an offset, and that I have just set to 20. And now we have a somewhat reasonable offset from the right side of the screen that we can use. So with that, I can close the init function and create another method all the way at the bottom. And let's call this one display lives. Doesn't need any arguments. And in here, I want to loop over my life. So for life in range self.lives. However, here I only ever want to display my lives -1. So let me explain what this does. Essentially, I want to have the ability on the top right to either show 2 lives, 1 lives, or 0 lives left. But with 0 lives, we are still alive. We just can't see any lives in the top right anymore. And this is, I think, how the original Space Invaders also worked. And this is why I want to have the -1. That we still have 1 life left, but we can't see it in the top right because it's our last life. So I hope that makes sense. And really all we want to do in here is to use screen.blit. We want to get myself.live surface. And now we are going to need an X and a Y position. The Y position is the very easy part. So we just need 8. It's a random number I've chosen because it's very close to the top. But for X, I'm going to put this in its own variable. And first of all, I want to get the left side of my starting position. So self.live X start position. And that is the variable we created up here, this one. So this is going to tell us when our lives should start on the left side. But we don't want to place all of our lives right on there. So we have to add something to it. And what we have to add to it is going to be, for now, our life. So this one here. And this right now would either be 0 or 1. But with this by itself, we would only move it by 1 or 2 pixels. So this wouldn't be good enough by itself. Instead, we have to multiply it by the width of the player life. So again, we have to get self.live surface, get the size again, and again 0. And this will place both of the lives right next to each other. And I want to have a slight offset, so let's add +10 to it. And this should give us all of our lives. So now in our run method, self.display lives, and let's see what's going to happen. And we are getting an error message. And the reason for that is, right here. Get size is a method. So I just forgot the brackets. And since I'm calling get size again down here, we also have to add it in there. Now let's try it again. And now this is working. Although the top right is a bit too close to each other. And this we can avoid by putting those two inside of a bracket. And now let's try this again. And this is looking better. So now we have a live system. Now the problem is it doesn't really work with our collisions. So this is what we have to work on now. That every time our players hit, I want to reduce our lives by 1. So effectively, we have to go back to our collisions. And in here, the important part is this if statement. That I don't want to print that anymore. Instead, I want to give self.lives -1. And what we can also do while we're here is if self.lives is smaller or equal to 0, then we want to end the game. So pygame.quit and sys.exit. And let's try this. So I hope I can get hit. There, it's reduced by 1. Now we have just 1 life left. And now you can see we can't see lives in the top. And now if I get hit again, we are dead. So this is working very nicely. And with that, we have our life system. Now, next up, I also want to add a score to all of this. And for that, we have to make a couple of changes to a few different things. We have to update our collisions and we have to update our aliens, so they all have a certain kind of score. So I guess let's jump straight back into the code and let's have a look at this. So here I have my entire setup again, and it is really getting quite extensive. But for now, I want to work on my init method again. And in here, I want to add 2 more attributes. The first of all is self.score. And by default, this is 0. And besides that, I also want to have a font, because now we have to display some text. And for the font, I need pygame.font.font. And the font I am going to import is also in the folders. And the file path towards that is this one. And the font size I went with was 20. So now we have a font that we can use. And that's all we needed in the init method. And now we can create another method that I have called display score. It needs self and nothing else. And in here, we have to do 3 different things. We have to first get a score surface, so we have to render the text. Then we have to get a rectangle of that surface, and then we have to put both of these on the screen. And this could be a really good exercise for you, that I want you guys to create this display score method and use it to display the score 0 on the screen for now. Ideally in the top left, but well, wherever you really want it to be. All right, so first of all, I want to create a score surface. And for that, we need self.font.render. And I want to create an f string that says score. And then we get our self.score. And for the anti-aliasing, I want false since we're using pixel art. And for the color, I just went with white. And with that, we have our surface. Now I want to get my score rectangle. And this is going to be score surface dot get rect as always. And in here, I want to place the top left. And for now, let's place it at 0 and 0. Although I'm going to change that in just a second. And finally, I just want screen.blit with my score surface and my score rect. And well, that's all we needed. So now I can open up the run method, and actually display lives should not be there. It should be down here. And I also want self.display the score. And I guess by now I can just delete these 2 comments. They don't really do anything anymore. And this run method has become quite extensive. It might be a good idea to clean it up a tiny bit. Let's do that now, actually. So here we are drawing all of this, and there we are updating everything. And I guess it is a good idea to have all of the update methods in one chunk. And that makes a little bit more sense. Yeah, I think that works a bit better. So here we are updating all of the sprite groups. Then here we are adding extra updates, and here we are drawing everything. Let's try this now. And we can see the score in the top left. And it doesn't update right now, but we can work on that in a second. But first of all, I want to work with this top left. And there might be one thing you have noticed, that this font is not in the top left. There's a slight Y offset, even though we specified 0 in the score. And the reason for that is that the font is rather large. So for the X offset, I want to go with 10, and for the Y with -10. And that's going to look like this, which I think is better. And well, the score here is just very, very tall for some reason. But well, that's literally all we needed now. So now we have a score. And the one thing we have to figure out now is how to update this number here. And for that, we have to go to our alien file and give each alien a score relative to their color. And well, that is literally just an if statement. So if the color is equal to red, then self.value is going to be 100. If color is equal to green, then we have self.value is going to be 200. And if we have neither of these cases, so we have else, then self.value is going to be 300. So this would be the yellow aliens all the way at the top. And now we can look at our collision checks in here. And the 2 if statements we want to look at are these 2. And the easier one is going to be this one, because there's only one extra alien. So if we hit that one, we want self.score plus equal 500. And that is all we needed here. and let me place it above laser.kill, not for any particular reason, it just feels better. All right, but now this statement here is going to become a little bit more complex. And that is because right now we are only deleting the alien once it's being hit, but we don't know which alien is hit. And since we don't know what alien is hit, we don't know what the score is going to be. So instead, we have to do this slightly differently. And let me actually copy all of this. And what I want to find out is first, I want to get all the alien, let's call it aliens hit. And this is going to be pygame.sprite.sprite collide. And it is still going to be true. And this is still going to destroy the alien. However, now it is also going to store it in this aliens.hit list. So I can get rid of all of this. And I can check if aliens hit. And if that is the case, I still want to get laser.kill. That stays the same. However, now I can also loop over all the aliens. So for alien in alien hit. And then self.score is simply going to be plus equal alien.value. Oh, and this should be for alien in aliens hit. And now let's try this. And it is working indeed. I can shoot at the aliens and I get different scores. And they hit the green one. And the score is updating quite nicely. I hope I can get to hit a yellow one. And there we go. So this is working very well. So with that, we also have our score. And that is basically finishing up the game by itself. So let me close everything. And I think what I really want you guys to get away from this is that none of this was particularly difficult. We just added lots of simple systems on top of each other and thereby created complexity. And there are only two things I really want to add. Number one is I want to add some CRT styling on top. And I think that makes the game look much better, although it's not strictly necessary and you might not like it at all. And the second one is going to add sound. And that's going to be the really easy part, so I will leave that for the end. But first of all, I want to draw on top of this. So by the end of this section, our game goes from this to this. But literally all we are going to do here is we are drawing some elements on top of the game and then reducing the opacity. And well, let's jump into the code and let's create this. So here I'm back in the main game and I want to create a new class. And let me minimize the game class so we have a bit more space. And this class I called CRT. It does not inherit from anything, and we just set an init method. And in here, I want to have self.tv. And this is just going to be an image. So pygame.image.load. And the file path for that is this one, so it's in the same graphics folder. And I also want to convert alpha this. And you're going to see in a second what that actually does. And what I'm going to do is I'm going to create a draw function that needs self. And for now, all we're going to do is screen.blit self.tv. And it should be in the top left, so 0 and 0. And now in our if statement for the main game, I'm going to create CRT as an instance of the CRT class. And then on top of our game run or below in the code, CRT.draw. And now let's have a look what this does. And there we go. So really all this does is it draws a TV style thing around the edges of the screen. But now this image has a problem. And let me actually demonstrate this. That if I increase the width of our game, now this image doesn't cover the entirety of the game, which starts to look very, very silly. So we have to add some code here to make this wider along with the screen. And let me move it back to 600. And for that, we can use pygame.scale. And well, all we are going to need is self.tv, is pygame.transform.scale. And in here, we need a couple of arguments. The first one is the surface itself, so self.tv. And then we're going to need the width and the height we want this to be. So in our case, this is screen width and screen height. And both of these have to be inside of a tuple. So if I run this by itself, we can't see any difference. However, if I make the screen wider now, this is going to scale up along with it. So this way our game keeps on being responsive, which is quite nice. But let me keep it at 600 to 600. And there's one thing that is kind of annoying right now. So we can't really see the edges too well. And this we can change by lowering the opacity of this surface. And to do that, all we need is self.tv and set alpha. And then here you have that a number between 0 and 100, with 0 being invisibility and 100 being the standard value so you can see everything. So let me put it to 50, and now this is looking much better. And what we can even do in here, because traditional CRT monitors flickered a bit, and I imitated that effect by using a random opacity between 75 and 90. And what is going to happen here is that every time we are running the draw method, so well, every frame, we are changing the opacity a tiny bit, which makes the entire thing look much more dynamic. And I think you can see it. This starts to feel better. So, all right, this is then working quite well. But now these old TVs also showed a couple of lines. And for that, I want to define, create CRT lines. And let's place this above draw. Again, we are going to need self. And now we need a couple of different things. First of all, I want to get a line height. So how tall each line is going to be. And I just went with 3. And then we have to figure out how many lines we want to have. So line amount. And really all we need is the screen height divided by the line height. And this I want to be an integer, so we can work with it a bit more easily. And well, all we have to do now is for line in range line amount, I want to draw the lines. And for that, I need a Y position. And well, this line position is just going to be line multiplied by line height. So we figure out what line we are on, and then we are multiplying this by the height of each line. And now we can start drawing. So pygame.draw.line. And here is one important thing, that usually when I use this .draw, I always draw on the screen. However, now I'm going to draw on self.tv. So self.tv. And the reason why I am doing that is because I want to have the same opacity for the lines and for the TV. And if I put all of them on the same surface, when we run this line, they are all going to have the same opacity, which makes the game look a bit more consistent. Now we are going to need our color, and in my case, I just went with black. And now we need the start point and the end point of each line, and a width. The width is the easiest part, I just went with 1. And for the start point, we need a tuple. And here we are going to need X and Y. And both of these are very easy, because X is just going to be 0, so the left side of whatever window we have. And Y is just going to be the Y position. And for the endpoint, this is also quite easy. So we need X and Y again, and Y is just going to be the Y position. And X is going to be the screen width. And well, that was literally all we needed. So now I have to call self.createCRTLines, and let's run this game. And there we go. This is looking very well. So now we have a much more retro feeling game that I think is looking better than the original. But you could just not run crt.draw, and then if you like this one more, this would also work just fine. And with that, we have all of our styling done. Now with that, we have the final part of our game, and that is going to be the music and the sounds. And well, there really isn't anything complicated now. This is going to be very easy. So let's go straight into the code and let's have a look at this. So here we have our entire game setup, and I want to look at my game class again. And if I open this one, you can see the init method and all the other methods we created earlier. And the first thing I have to do is to import all the music. Let's call it audio actually. And first of all, I want to import the music itself, so the background music. And this is going to be pygame.mixer.sound. And the file path towards that file is this one. Next up, I want to set the volume of this file, and I set it to 0.2 so it doesn't get too loud. And finally, I want music.play, and for the loops, we want to set it to -1 so it displays forever. And now, if I run this, you should be able to hear the background. So I hope this is working. So this would then be the first part. And this could be a really good exercise for you. There's also a laser sound and an explosion sound. Try to import them, set the volume, and play them at the appropriate time. All right, I'm going to shorten this a bit because this is very samey. So let me just copy them. And here we have a laser sound, and we set the volume, and then we have an explosion sound, and we're also going to set the volume. That's literally all that's happening here. So now we have to figure out when each of these sounds is supposed to be played. And let's start with the laser sound. And the laser is going to happen every time an alien shoots. So in here, alien sound.play. And the explosion sound, I want to play if we have a collision check between the player laser and the alien. So in here. And let's just play it right afterwards. And let's try this. Okay. Although there's one part missing, that if our player shoots a laser, we don't hear sound. And for that, we have to go back into our player class. And in here, I also want to import the laser sound. So here, the literal same thing we have done earlier. And now every time we're pressing the space button and we are ready, I want to self.laser sound.play. And now let's try this again. Really well. However, there's one thing I did forget, and that is a victory message once we have destroyed all of the aliens. So let's add this one really quick. Sorry about that. But this is not a difficult thing to add. And really, all I want to do is if there are no more alien sprites, I want to display a text that says you won. That's literally all it is. So let's jump straight into the game and let's fix this really fast and then we are finished. Here we're back in our game class and I just want to add another method. And let's call it victory message. Doesn't need any arguments. And really, all we're going to check in here is if not self.aliens.sprites. So if there are no more aliens in the aliens group, then we know we have won. And in there, all we need to do is create a victory surface. And this is going to be self.font.render that says you won. Needs to be false for anti-aliasing, and the color is going to be white. And then I also want to get a victory rectangle so we can place it in the middle of the screen. And this is just going to be victory surface.getRect. And the center is going to be the screen width over 2, and then also the screen height over 2. And then finally, screen.blit victory surface and victory rectangle. And then, of course, also don't forget to run this. So self.victory message. And for that, I am going to cheat ever so slightly here. So what I'm going to do is in the collision check, I am going to comment out laser.kill and replace it with pass whenever our player hits an obstacle. And we're also going to comment it out whenever we hit an alien. So that way our player is basically going to shoot through. And there we go. Now we're messing. But now it is complete. So now I can uncomment all of this. Get rid of this. And with that, we have the entirety of the game. So I hope that was helpful, and I will see you around.